10.2, number 45. We've got an airplane flying in the direction 20 degrees east of north at 325 miles per hour in still air. Alright, so I'll do it geometrically first. So with my drawing here, I've got an airplane flying in the direction 20 degrees east of north. Alright, so 20 degrees east of north, I'm going to go maybe like this. It's not quite 20 degrees, but I'll say that's 20 degrees. And it's traveling 325 miles per hour. And then we also have a 40-mile-an-hour tailwind acting in the direction 40 degrees west of north. Alright, so I'll draw my auxiliary lines. So here's my north-south, here's my east-west, and it's going 40 degrees west of north. So we'll say it goes like maybe right there. So this is 40 miles an hour, and it's also 40 degrees west of north. And we're supposed to, the airplane maintains its compass heading, but because of the wind acquires a new ground speed and direction. What are they? So we need to know how fast it's traveling and what its direction is. So here is our resultant vector. We're looking for the blue vector. How long is it? And that'll tell us our miles per hour. What the direction is, we're going to need an angle there. Alright, so using our geometry, so that's 20 degrees, this is 70 degrees, that's 90, this is 20, which means this is 70. If that's 40 degrees, this is 50 degrees right there. Alright, so maybe I'll do a different drawing, one we can work with a little better. Let's see, I've got 70 and 50, so that's 120 degrees. I also know that this is 325 miles an hour, this is 40, and we're looking for x. X will tell us how fast the airplane is traveling. Alright, so we have a side angle side scenario. That's law of cosines. Law of cosine says the opposite side from the angle, which is in the middle, squared, is equal to the other two sides squared and added together. Minus 2 times the side times the other side times the cosine of the angle 120 degrees. Alright, so that will give us a number. We'll take the square root of it, plug it all into our calculator, should get 346.7 miles per hour. So we know how fast the plane is traveling. That's how long that blue vector is. We also want to know the direction of it. So we need to figure out what this angle is right there. I will call it theta. Okay, so this is, we're going to have to use law of sines for this one. So we have theta, so I'm going to say the sine of theta over its opposite side, so 40, equals sine of 120 over x. Oh, x we know is 346.7. Alright, so we're going to cross multiply this times that divided by that, so 40 sine of 120 divided by 346.7 is equal to the sine of theta, inverse sine of that, and we get our angle. Make sure you're in degrees. That's like, let's say 5.7 degrees. Alright, so back at our drawing here, this is 5.7 degrees. Let's try to figure out this one, and then we can say how many degrees east of north it is. So this is 20 degrees, that's 5.7, so this would be 14.3 degrees. So it's 14.3 degrees east of 7 miles an hour. Okay, so that's one way of doing this problem. If you are good with learning it that way, then you can stop watching the video. I'm going to show you a different way of doing it just by adding the components of the two vectors and getting the same result, hopefully. Alright. Our first vector we said it's traveling at 325. That's the plane itself, and we could break that up into components. So we know that this is based off our drawing. We can figure that's very fuzzy drawing, but it's 70 degrees. Okay, so if that's 70 degrees, then I can figure out my horizontal and my vertical components. So I can say sine of 70 equals y over 325. So my y is 325 sine of 70. My x is just going to be the magnitude times the cosine of 70. Okay, so one vector, the plane vector, I've got a 325 cosine 70 comma 325 sine of 70. Alright, our second vector is the wind, which is traveling at 40. I'll make it a little bit longer. So what are the horizontal and vertical components? From our drawing, you can see that it's a 50-degree reference angle, so that's 50, x and y. So again, sine of 50 equals y over 40. So my y is 40 sine 50, and my x is 40 cosine 50. But remember, the x is traveling left, so that's going to be negative. The y is positive because it's going up. So my other vector is negative 40 cosine 50, comma 40 sine 50. And if we add them, all right, let's see, 325 cosine 70 minus 40 cosine 50. I think we get 85.45 comma, and I don't know what we get that, 325 sine 70 plus 40 sine 50, we get 336.04. Okay, so we got our resultant vector. This is the blue vector. We've got it broken up into two, the horizontal and the vertical components. We still haven't answered either of the question. But if you want to know its magnitude, you use the Pythagorean theorem. So that squared plus that squared, 85.45 squared plus 336.04 squared equals, and then the square root, we get a syntax error. Nice. Try that again. 85.45 squared plus 336.04 squared equals, and square root answer is 346.7 miles per hour, and got the same answer as what we had up there. Okay, so if we wanted to know its direction, we could, remember, this is just the blue vector right here, so we know the horizontal and vertical. We could do the inverse of our vertical divided by our horizontal, opposite over adjacent, and we get 75.73. Okay, so that's the angle that it makes with the horizontal. If we want to know this, it'd be 90 minus our answer. We get 14.3 degrees right here, 14.3 degrees east of north, and that's what we had up there also, 14.3 degrees east of north.